Okay, so binomial theorem, it really helps us with expanding by essentially a binomial. Binomial's function that has just two terms. The addition sign kind of separates it for us. The n means any number of terms. So before, when you work with quadratics, they usually would call this like a 2, or if it's a cubic function, you remember being 3. Well, this could become infinitely large. So they developed something called Pascal's triangle, or Pascal did, to help with the expansion of these so they wouldn't have to go through the entire process. His triangle, if you've seen it before, the first level is just the number 1, right? The second level, this is what actually stands for our binomial, okay? Second level, as in there's two terms here, okay? So we actually don't start with the first level when we go through this, and this is not to the power of 2, that's to the power of 1 in this level. From there, to go through the triangle, do you know how to create the rest of it? Yeah. 1 stays on the outside, and we just add up the middle terms, and we continue down that. So that would take us to plus b to the power of 2. Right? And that makes sense if you remember doing any of your quadratic stuff, right? So in this one, they want us to go down to the 5th level. So in other words, this is 2, 3, 4, 5. So if we take this down to the 5th level, the next values will be 1. What do you know what would be inside?
3, 3, 1.
Yep. And then
1, 4, 6, 4, 1.
And then in the 5th level?
1, 5, 10, 10, 5, 1.
Good. Okay, so this takes our 5th level. How many terms do we have in here?
6.
Yeah, we have 6 terms. So it pretty much, as we go through this, and you'll notice in our 2nd level, there are 3 terms. Whatever our exponent is, in terms of the number of terms, we're pretty much 1 above that. So when they ask you for something, how many terms would be involved, and something that's to the 5th exponent, well, there'd be 6 terms. If they asked it to the 7th exponent, well, there would be 8 terms involved in the expansion of that. Okay? Now, let's actually go about the expansion of this. When they go to write these values down, you also, when they do it, is they'll attach these 2 parts of the exponent. So your a, for instance, in this term here, let's say we're in the 2nd level, a will be to our power of 2, okay? And farthest to the right, our b will be to the power of 2. And then we'll subtract as we go along, left and right. So if we're taking, say, the b's to the left, we take away one of the exponents. So in the middle term, it'll just be b to the power of 1. And we do the same thing with a. When we go to the other direction, to the right, this becomes a to the power of 1. So then if I were to write a in here, it would be technically to the power of 0, which means this is the value of 1, so we don't write it. And the same idea here, we had b squared, b1. This would technically be b to the 0, but we don't really write it in. Might sound confusing. Let's try the next row. So let's say row 3, and I'm going to rewrite these on the other side in blue. So in the 1st level, we have a plus b, and technically a to the power of 1, and b to the power of 1. Okay. Our next term here, we're going to have a squared. Okay. And what we do with Pascal's triangles, we actually take these as the coefficients. We put these as the coefficients in front of them. So because we're on the 2nd level here, we would have the number 1 involved. Now b would actually be, I guess we'll do b's in green just to keep it a little different here. B would be to the power of 0, okay? Because we're counting down. So the highest exponent I can actually have is 2, because my binomial is to the power of 2. So I start on with my first term, which is the a, and put a to the power of 2. The last term will start at 0, and then it will count up as a counts down. So the middle term, our coefficient, as we took from here, is technically the number 2. So we could say we're adding 2. A now counts down an exponent. A becomes to the power of 1. B goes to the power of 1. It's counting up. And then with our last value, I'm just going to squeeze it in, our coefficient is still 1 again. Now A is to the power of 0, so it's technically non-existent. We don't have to write it in. And B is to the power of 2. Okay? So for the ones where we have powers of 0, we don't usually include them because they really just equal the value of 1. So we wouldn't put that in. Okay, so let's see if we can't go to the 2nd level here. And what we'll do, as we go through this, we'll go through the expansion of this also. Okay, and I'll show you how this expansion works. I'm going to rewrite that down here, so don't forget it, 2x minus 3y to the 5th. Okay, so as we're going through Pascal's triangle here, we already wrote our 2nd level, okay? we know this has to go to the fifth level. So if we want to write this in, these are all of our coefficients. So I can write my coefficients in the start if I want. This is going to be equal to, coefficient is 1, okay? My a value, and this is my b value. Well, the entire number, you could say, is our a value here, okay? And this is our numbers, whoops, that is the b value, that entire value here. So when we go to write this in, our a value is going to be to the power of 5 when we start. That's one farthest to the left. So we're going to have 2x to the power of 5. Okay. Our b value is going to be to the power of 0 here, so I don't have to write it in. So then we go to the next term. The next term's coefficient, because we use Pascal's trying to figure it out, is the number 5. Well, in this one, our a term, which is 2x, is to the power of 4, but our b term is to the power of 1 in this one. And it's actually, the b term is a negative 3. I just want to make sure. Pretty sure it is. That becomes to the power of 1. Does that make sense? That's that?
Yeah.
Yeah? Okay. So, and if you want just to keep an eye on the side, so this is where we would have a at 5. This would be a at 4, b at 1, right? All I'm doing is substituting the actual values in. So, the next term in here, and remember, each of these represent a term. This is only the first term. This whole thing here is only the second term, okay? The third term, we have 10 as our coefficient, so we're still going to have to multiply by 10. And then we go down with our a terms. So, do you want to tell me what you think it would be?
2x to the power of 3.
Yeah.
And then negative 3y to the power of 2.
Yeah, that's right. Exactly. So that's our third term here, right? And that's because our a would be cubed and our b would be squared. Now I'm kind of running out of room here, so I'm going to try to, I don't even think I can squeeze those in. Let me see. We'll try our best here. Okay, so tell me what the next coefficient would be.
10
Yeah.
at 2x to the power of 2 times negative 3y to the power of 1.
That's right. Oh, sorry. No, you did make one mistake.
Oh.
It's not to the power of 1.
Oh, I mean 3.
Yeah, that's right. This one's counting up. Good. Next one.
5 times 2x to the power of 1 times negative 3y to the power of 4.
That's right. And then we're just going to squeeze the last term in underneath here. What would it be?
1 times 2x to the power of 0.
So do I need to write that in?
No.
What will that become?
1.
Yeah, it'll just become a 1, and 1 times anything is going to be itself. That's why we left it out of the first one, the b at the power of 0. So we can pretty much just write negative 3 to the power of
5.
All right. So now we're going to actually have to equate this thing, okay, as we go through it. So as we equate this, the first one shouldn't be too hard. This is 1, so 1's not going to change anything. This will be 2 to the power of 5, and technically x to the power of 5, okay? Think of it like you're multiplying that number by itself 5 times. So I'd be multiplying 2 by itself 5 times. So I can just write it as a power like that. 2 to the 5th power, I'm pretty sure it's 32. Quite sure it's 32. So 32x to the power of 5, okay? So there's our first term. Now in our second term, before I put an addition or subtraction sign, or actually I can, I'll put my addition sign and then we'll talk about what happens after. We're going to actually have to do the equating here. 2 to the power of 4 is going to be 16, okay? Negative 3 to the power of 1 is still going to be negative 3, and we still have to multiply that by 5. So I haven't dealt with the variables yet. I'm just focusing on the coefficients, or the actual numeric values. So 5 times, this will be 16, times negative 3. I'll take a calculator out. Do this a little quicker. So we have 16 times 5 times 3, and then because we're multiplying by negative 3, what will this be?
Negative.
Yeah, exactly. So we have negative 240 is going to be our value. So technically, I shouldn't be putting this positive value in. This should be a negative number right now. So negative, all right, negative, what do we say, 240? Yeah. X will be to the power of
4.
Yeah? And y will be to the power of?
1.
1. And that's it. And we would just continue this process as we go along. So let's try it. Let's see if you can get it. The next one, first of all, will it be a positive or a negative?
Negative. No, positive.
That's right, because the negatives are going to double up, right? So we're going to have a positive value. 2 to the power of 3?
8.
Yeah. 8 times 10?
80.
80. And then negative 3 squared will be?
Negative 9.
Not negative 9, because the
9.
negative, yeah. So 9 times 80, and that's going to give us 720. That should be 720. Okay, tell me about the exponents.
X cubed.
Yep.
And y squared.
There you go. Okay, so we're already on our third term. Let's try the next term here. When we add these up, that's going to be a negative or positive value?
Negative.
That's right. We're going to have a negative value. This is going to be negative 27 times 4 times 10. So let's try to solve this a little quicker. Negative 27 times 4, and then obviously times 10 is negative 1080. Okay, so 1080. Our x value will be what?
Squared.
Yep.
Y cubed.
Yeah, you got it. Okay, and then our last one's here. Take the calculator again. Negative, whoops, that's not how you do negatives. Negative 3. There we go. Negative 3 to the power of 4. Okay, times 2 times 5. 810. Positive or negative?
Positive.
Yeah. Shoot, I forgot the number. Did we say 810? Yeah. And then our x will be to the 1, and our y will be to the 4th. And then finally, the last one, it's essentially just going to be the 5th power of that.
Is y to the 4th? Or?
Oh, yes, it is. I forgot to put the other part there. And then finally, our last value here. Negative 3 to the power of 5, negative 243. Negative 243, and then y to the 5th. So, does that very long process make sense?
Yes.
Yeah. Okay, that's the whole use of Pascal's triangle when going through this, is we use that for our coefficients. And essentially with the exponents of these values, you really just start at whatever the exponent is on the outside with the a term and count down to the left. And you start with that same exponent on the right for the b term and count down. That's to the left, the other one's to the right. I gotta learn my left and right. Does that make sense?
Yeah.
Okay, so that's how we use Pascal's triangle for binomial theorem.